Good afternoon, everyone. Yes, I am audible.
Yes, sir, you are audible, sir.
So, actually, Dr. VAIBHAV sir is joining late by 10 minutes. So we'll start the session at 2:10. Sorry for the inconvenience. I posted the message also in the group regarding the same. So we have to wait for 10 minutes to start the session.
Yes, our next speaker is also in our group. Welcome, Sukumar Roy.
Yeah, good afternoon.
Good
Good
afternoon. Good
afternoon, sir.
afternoon.
Yeah. So, yes, I think the other two presentation will going on, and then I'll be
Yes, yes.
on the
Uh,
board.
sure, sure, sure.
Okay. Okay. Thank you
So
very much. Yeah.
I will pin you just when we'll starting the because see continuously three sessions are been there. So what we'll do, we will take one at a certain point we'll take one particular technical break so that recording and all the things will be going on properly for each and every session.
Yeah, yeah. That's fine. That's fine. Yeah. Okay. Okay. Thank you.
Yes, sir. Thank you.
In the chat box, I have provided the YouTube link of all the session of the previous 5 days, and today's session link will be uploaded in the night. So from tomorrow morning, we can see all the 13 video link in the YouTube channel. So please subscribe that channel to to listen all the videos of our sessions. Those which have missed the session during the working hour, so they can listen all the session from the start to end. We have recorded all the meetings with the annotation, so it is beneficial for all of us. All our speaker, most of these are from the IIT, IIT Guwahati, IIT Chennai, IIT Bombay, professor from ICT Mumbai, as well as VNIT Nagpur, and one from OMA. These are our faculty member in the teaching field, and remaining from the industrial, there are around 7 speakers from the industry. Today, we have Vaibhav Gaud sir. After that, the Mr. Abhijit Rao, he is the Jacob engineering expert in the piping engineering. So I think here Chetan Kapalni sir is here. Sir is also an expert of this piping engineering. So after that, Vaibhav Gaud sir lecture. There are two sessions. Both are the experts in the piping engineering and process engineering. And today will be a great day for our Atal FDP program. So everyone, please be attentive for the today's session because all the session, Dr. Vaibhav Gaud sir, Professor IIT Guwahati, Waste to Fuel. I think more than 100 research paper is published by Vaibhav Gaud sir on the waste to fuel for a greener future. Madam will introduce afterward. After that, both the speaker are from industry. I think Sukumar Rai sir, which has around 30 to 35 years of experience in the process engineering and piping engineering. Also, Abhiz Arao sir, which has also experience of 30 years. So their lecture will be fruitful for our this FDP. So please be attentive. I know that today is the Saturday and it is very difficult for all our teaching faculty to engage in such type of lecture. Also, Diwali is there. I know all these things, but for our future generation, we have to work on this. Thank you very much. Whenever the Vaibhav council join, then we start the session.
Thank you, sir. Because all whatever the three speaker we have been having today are the good speaker, and throughout that we try from our end that there should be any some particular good speaker from our end. So from starting from Madhini sir to till Sukumar Rai, all these particular the good speaker was been there, industry and as well as academician. Ingo sir, can we, because meanwhile participants are getting joined, meanwhile just we can brief regarding the examination, will you brief regarding that? The link starting, then terms and condition and all the things, that how the way the examination will be get conducted, and after that for the certification what kind of activities has to be done on the portal. So can you, because those who had been previously, those who have been done the Atal, they might be knowing all this particular thing, but those who had been not knowing might be not knowing this particular such thing.
Okay, sir. Regarding the examination, as per the Atal FDP guidelines, in the exam paper, everyone should get minimum 70 marks, and this exam is carried out in the Atal portal. So we don't have any in our hand to increase the 2 mark or 4 marks, so which will fail from the 2 mark or 4 mark. So the exam will be taking place on tomorrow at 11 a.m. That link will be open from tomorrow 11 a.m. that is Sunday 11 a.m. to Monday 11 a.m. Timing of the exam is of 1 hour. Means whenever you open the link, if you open the link at 12 p.m., then your link will be closed at 1 p.m. It is not like this. Link will be open for completely 24 hours. For exam purpose, it is only for 1 hour. That you can take the exam on any time from 11 a.m. from Sunday to 11 a.m. on Monday. The exam consists of multiple choice questions, simple exam. It consists of multiple choice question having a 50 question, multiple choice question having a 50 question, each question carrying a 2 marks. So to get the certificate, we at least require 35 question to be correct one. So if you get the 70 mark, then your certificate will get. In today morning, I have posted the message in the group. There are 8 to 9 participants which are not joined up till now. So their attendance is very less. So they cannot appear for the examination because also there are two criteria of the Atal FDP certification. One is we required 80% of attendance, and second one is the 70% of mark in the examination. So certain faculty member had not joined. They are registered for this FDP but not joined for this any one session of this FDP. So there are 7 to 8 participants are there. They are not eligible for the examination purpose. First thing. So for examination, you have to log in your Atal portal. Some faculty member also does not remember which email ID they have used during the registration of the Atal FDP, because each and every faculty has using more than 4 to 5 email IDs. So it is very confusing for us which email ID we are used for the Atal FDP registration. I will provide the details of the your mail ID from which you have registered for the Atal register on the Atal FDP portal. So you have to log in with your that email ID to the Atal FDP portal. In Atal FDP portal, there is a test section in the right hand corner. राइट हैंड कॉर्नर में आपको टेक्स्ट सेक्शन करके मिलेगा, तो क्लिक ऑन दैट टेक्स्ट एंड टेक्स्ट के ऊपर आप क्लिक करने के बाद में यूर लिंक विल बी ओपन। तो वहां पे आपको वीडियो ऑन ऑफ करने का कोई जरूरत नहीं है। इट इज नॉट दिस जस्ट एग्जामिनेशन, नॉट एनी प्लेगरिज्म टाइप ऑफ इशू देयर। सो
So in case of any assistance, if you require, just you can also contact to us. If you find any difficulty for getting to the portal towards direction towards the examination, you can call us. Meanwhile, Ingole sir, our today's speaker is also joined. Good afternoon, Vaibhav. Vaibhav sir, good afternoon. Am I audible, Vaibhav sir?
Yeah, it's audible. How are you?
Yes. Good afternoon. How are you?
Yeah, I'm fine.
I think it's a long time. I think
Yeah.
more than 25 years.
25 years, right.
Yes. Nice to see you here as a FDB speaker. We used to have your NPTEL courses. We used to most of the time opt your NPTEL courses also.
Roy was telling me yesterday actually.
Yes. Ingol sir, can you make my video on?
yes sir.
Yeah.
Good afternoon, Vaibhav sir.
Good afternoon. Actually, my video, I'm just trying to make it on.
Yes, sir. Just we will start the session. If you have been ready with your presentation, we will start
Yeah.
everything. Okay. So
Sir,
yes.
your video on.
Yes. Nice to see you once again, Vaibhav sir. It's a really pleasure to have you as a today's speaker. Yes. So I will request Rushale madam, you just formally just introduce today's speaker so that we can start our session. Rushale madam, if you are ready, you can start the session. Rushale madam.
Just give me 1 minute. Actually, this video, I think it was working, just got disconnected. I will just log out and log in again.
Sure.
Yeah.
Sure. Take your time. No issue. Meanwhile, Rushale madam, are you ready with the formal introduction of our speaker? Rushale madam.
I will call you. Just a minute. So madam is joining in 1 minute.
Okay, sir. Okay.
Yeah, I guess now this is working. Yeah.
Yes, it's working. Your video is also on now.
Yeah,
It's working.
now it's
Yes.
visible, right?
Yes. Sorry to trouble you on the weekend, Saturday.
Yeah, no, it's okay.
Good afternoon, sir. Am I audible?
Yes, you're audible.
Yeah.
Now you can just formally, you can just introduce today's speaker.
Yes, sir. Good afternoon, everyone. Welcome all to the 11th session of the 6th day of AICT Atal Faculty Development Program on Emerging Sustainable Practices in Chemical Engineering, organized by the Department of Chemical Engineering, Datta Meghe College of Engineering. Myself, Dr. Mrs. Rushali Rao, on behalf of our respected principal, head of the department, faculty, and organizing committee, I take this opportunity to welcome our esteemed resource person, Dr. VAIBHAV GOUD, sir. It gives me great pleasure to introduce a distinguished academician, researcher, and innovator, Dr. VAIBHAV GOUD, sir, professor in the Department of Chemical Engineering at the Indian Institute of Technology, Guwahati. Dr. GOUD earned PhD in chemical engineering from IIT Kharagpur, and since then, his journey has been marked by the excellence and innovation. He has held key academic and leadership positions, including head of the School of Energy Science and Engineering, chairperson of the Technology Incubation Center, and academic coordinator of the IIT Guwahati GIFU University Joint Program. With over 165 peer-reviewed publications, 5 books, and more than 12,000 citations, Dr. Goud's contribution have been recognized globally, including being listed among the top 2% of the scientists worldwide in the field of chemical engineering by Stanford University. His pioneering research on biofuels, biorefineries, and sustainable energy technologies has not only advanced scientific understanding but also led to the industrial innovations and patents that bridge academia and real world impact. He has 3 patents and he is the mentor of around 28 government funded projects. Today, we are honored to have him with us, uh, a visionary scientist, inspiring mentor, and an exemplary leader who continues to shape the future of sustainable energy and chemical engineering. Please join me in warmly welcoming Dr. VAIBHAV GOUD, sir, for the session entitled Waste to Fuel for Greener Future. I also extend a hearty welcome to all the participants from various institutes and organizations who have joined us for this FDP. Your active engagement will definitely make this program a great success. Without further ado, I would like to ask respected sir to begin his presentation. Over to you, sir.
Yeah, thank you for such a brief introduction and also providing us this opportunity to present the research finding and share our research work amongst the different academic fraternities present here in this forum. So without much delay, I would like to just share my slide and just let me know whether these slides visible to you. So if these are visible, I guess.
Yes, visible, yes.
Yeah. So just let me know whether these slides are moving.
Sure, sure. If any some particular error has been there or any particular issue has been there, we will be just at the time we'll just will interrupt you.
Yeah, just let me know. I'm just moving the slides. Can you see the slides moving?
Not right now.
Oh, is it? Oh, wait a minute. So I guess now it will be fine. So is it
Yes,
moving
it's
now?
moving now. Yes, moving.
Yeah. So, okay, without further delay, let me first of all express the sincere thanks to all the organizer of this FDB program as well as the Datta Meghe College of Engineering for inviting me for this particular presentation, or you can say about this particular talk. As the topic mentioned earlier, it was on the waste to greener fuel. So I'm just trying to pick some of the findings which we have done some research related to the relevant area, and then try to convert that into a kind of the fuel, which we all know that today's era, actually the ethanol is getting blended in the petrol, so it's becoming one of the popular fuel right now. So just trying to have some glimpse on that particular part of the research. And although we know there are certain refineries which are already producing the ethanol in the country, and there are many plants which are operational now from the lignocellulosic biomass as well. And although these are different techniques, all the techniques may not be similar to all the refineries, or we can say all the plants. Everyone has their own technique of producing this ethanol. So we just try to venture into some specific method where we can see like how most greener way we can produce sugar as well as then ferment it to the ethanol. That was the main area of the research which I would like to highlight in today's presentation. And based on that, the title I have selected is like dissolution of lignocellulosic biomass using the ionic liquids, because as we know, a dissolution in the sense is like as we know the structure of the biomass. So considering that, the dissolution we are considering, that is the dissolution of the selective component of the biomass. So in that we'll mostly discuss about how to screen these ionic liquids, because this is very essential in this particular research, rather than spending too many hours, man hours on just doing the experiment. It is basically a wastage of time. So rather than let us screen the ionic liquids and use it for the application purpose. And then the effect of anions and the cations which are present in the ions, that was one of the major important point in this particular research. Then the reaction mechanism, obviously, when we select the ions, how they will get combined with the particular you can say component to form a complex, and that complex will take it out from the mixture. And then the biomass dissolution, composition analysis, obviously, of the material, and then the enzymatic hydrolysis. Once we hydrolyze it, we'll get the reducing sugars form, that is nothing but in the form of glucose and then the xylose, which are the potential source of the fermentation technique. So all those things we covered one by one in the upcoming slides actually. So before that, as we know, the biomass is a well-known term which is widely known for most of the researchers nowadays, like what is meant by the biomass. So I will not go in detail of that particular terminology, I would say. Rather, I will just brief you about like what is biomass first. Let us understand that, because it varies. So once we see the source of biomass, we'll have there are different sources. So obviously the biomass will have the different composition. So once the source is varying, the composition obviously will vary accordingly. So to wider extent to understand that, we have considered the composition in the wider presentation as well. Like cellulose, it is varying from say 30 to 50%. Hemicellulose, it may vary from this percentage, and the lignin. So now these are the potential components which are present in the biomass, and how to separate it out by dissolving it. That was the target research area which we focused, and then we could able to succeed to a relevant field, and could able to dissolve around like 90% of this material in the ionic liquid. That was the achievement of the entire research. And then, as we know, there are a number of techniques available for the dissolution of this biomass, because this area, as I mentioned, is a very well-known area for the greener fuel, or you can say the biofuel. So as this material, as I mentioned, it's a very complex composition of the biomass. So we require a certain pretreatment technique. That's why I mentioned here the pretreatment of the biomass for the production of the fuel. That means how to pre-treat. Pre-treat is nothing but sense like we have to just treat chemically, or maybe you can do non-chemically also, so that you can loosen the bond between these particular component here which are present. So that is the target thing, is like how to loosen this particular bond structure. And once you loosen it out, those particular things will come out from the matrix automatically. So for that you require a certain harsh treatment technique as well sometimes. And if not, then you need to select a specific cation anion which will interact with this component, and then they will take it out this particular component from the complex mixture. So that way we focused on various research areas here. So practically, if you see, there are different Pretreatment techniques which are available, like if you talk about alkali, hot water, acidic, steam explosion, ionic liquid, subcritical water, supercritical water, many. But then when you talk about the greener approach, then only technique which comes into the minds are nothing but ionic liquid and subcritical, supercritical water. Why is it so? The reason is because when you see this technique, just a minute. So subcritical and supercritical water in the sense it doesn't require any chemical. So with the help of water only, you can do the complete dissolution. So that is what is the beauty of this particular process. And subcritical is nothing but below supercritical temperature range. Supercritical is nothing but the supercritical temperature range of the water. And in that we selected the ionic liquid because we don't want to go for the harsh treatment also. But although we worked on these two treatment as well. So ionic liquid we can do with the lower temperature range. So that is the idea behind using the ionic liquid for the dissolution study. And this is very well-known topic in the literature now because a lot of literature papers have been published on this particular area right now, and a lot of commercial activities are happening in this area. So, for example, when you say the lignocellulosic biomass, which has this composition, so how, because once you have, say, for example, this is the composition of the biomass, which is tightly binded by its complex, or you can say by the different bonds together, right? So now, if you have to break this bond, you require certain key element which will break this bond, and then we separate out the hemicellulose part, the cellulose part, the lignin part, and then the other. Other in the sense is like I will talk about the others in the subsequent slides when we see the biomass structure. So these are very important components which need to be dissolved in ionic liquid, or you can say organic solvent, or by any other solvent if we by means of doing the pre-treatment. But when you say the organic solvent, again the problem is like the vapor pressure of the particular organic solvent is a critical issue again. Then handling of those organic solvent is another issue. How to reuse this particular organic solvent in the downstream processing is another issue. So those all questions will be answered by one liquid that is nothing but called as a ionic liquid. I did so because when you talk about the ionic liquid, these are nothing but the combination of the cations and then the anions. So you can select the cations, you can select the anions from the bunch here, and you can prepare the ionic liquid. So likewise, there are more than 400 commercial ionic liquids are available in the market. You can select one and start doing the research. But then the issue while selecting such particular ions is whether that particular ion is effective enough to dissolve a component which are present in the biomass. And how do you know that whatever the selected ions is an effective ion for the specific biomass? That we cannot guarantee, right? Either we need to test all these for 100 commercial ions, or I need to select a specific ion which is very effective for the biomass dissolution. So how to answer this question? So that particular question can be answered by doing the screening of the ionic liquid. Because otherwise this question remains as a question. And if suppose I am doing a research with specific ionic liquid today, and after 4 years somebody is coming with certain different ionic liquid saying that no, this ionic liquid is the best one for the dissolution, whereas the previous one used was not that effective. Because there was no comparative things or no screening has been done for the ions. So that particular thought process taken into mind, we have started doing the screening of the ionic liquid first. Because if I talk about the combination of the cations and the anions, so effectively you can say more than 10⁶ possible ions would be possible to produce. But then is it possible to test all these ions practically or on the bench scale? It's impossible task, right? So what to do is like it's better to go for the selection of the, or you can say the screening of the ion. That is more effective, right? So that we started doing using the ionic liquid. So now why specifically the ionic liquid for the biomass dissolution? As I mentioned, because it also can act as a catalyst along with the solvent, with the solute. The ionic liquid also plays a role of the catalyst. That is the beauty of the ionic liquid, and can replace the organic solvents completely. So complete replacement of the organic solvent is possible if you select a specific ionic liquid. The low vapor pressure is another important point of the particular ionic liquid, because if you try to use organic solvent like kind of the ethanol, methanol, petroleum ethers and all, the vapor pressure is relatively high. But these ionic liquids have a very low vapor pressure, and thermally and chemically they are very stable. If you heat up to 300 degrees, 50 degrees C also, they remain as it is. There won't be any kind of the distortion at the chemical bond, and thermally also you cannot see any change in the phase. So you don't get converted into gases even. So right. So that is the advantage, and the flammability issue is not there. Non-toxic, another important point, and then high ionic conductivity, and because of this ionic conductivity also, these ionic liquids are playing a very, very important role in the even the, you can say, heat transfer fluid as well. So that is another important part of this. And wide range of the temperature range, you can use like up to 300 degrees C. You can take this particular material for the resolution. That is advantage of it. If you talk about any organic solvent, it cannot reach to even 300 degrees, not even more than 120 or 130 degrees C. So that is the advantage of this ion. And eco-friendly, another advantage, reusable, like you can reuse this material, as I mentioned, you can reuse it for multiple times. That is the advantage of these ions. And then reduce the process cost, ability to fine tune the properties, because once you select the ionic bonds and the cation bonds, so you can similarly fine tune the properties of that specific ion which is required for your research, and that's why it is called as a green solvent. And then considering that part of the green nature of the process, we have selected ionic liquid for the dissolution. And this is very well known structure of biomass, as most of you must be knowing about this particular structure. But just wanted to give a glimpse of this, why the dissolution is very important basically here. Because if you see this green mat here, the green mat is nothing but the continuous matrix here, right? That is called as a cellulose. And these dark green threads, which you can see on this green mat here, which are nothing but the hemicellulose fraction which are present in the biomass complex. And these green, you can say the brown color one threads which are present on the outer wall. These are acting as a shield to both these mat as well as this thread of the dark green color, and which protects this entire plant cell wall, right? So because of this nature of lignin, it is very difficult to access this green mat as well as this dark color green threads, and then it's very difficult to dissolve this material. And to do that, either you require very harsh treatment technique or very harsh chemical techniques. So, but then again, it incurs the cost as well as the downstream processing cost, which effectively basically increase the cost of the process. So, to replace that particular part, we have chosen the ionic liquid for the research. And why it is essential to use the ionic liquid? Because it plays effectively a double role in the process. What do you mean by the double role? Because if you see these matrix here, as I shown, the outer one are nothing but the lignin. These greens are hemicellulose, and this blue indicates the cellulose part of the plant matrix here. And these cellulose are bounded by this kind of the crystalline structure of the cellulose. We can say the cellulose. So the cellulose are nothing but like the glucose or the cellulose moiety, which are linked together in this linear chain manner. You can have thousands of such compounds together attached, which form a natural polymer that is called as a cellulose molecule. And then breaking this molecule itself is a very tedious process, because we need to break down and convert this into a small molecule like this glucose here, if you see this part, or maybe you can say the cellulose here, if you see. So the breaking of this bond between these layers is also very important, and that effectively is possible to do using this ionic liquid along with the dissolution process. That was the main advantage of doing this ionic liquid treatment with the biomass. So why biomass? Again, as I mentioned, because it's an abundant source of naturally available material which can be converted into a usable form of the fuel, or as well as the intermediate fine chemicals. For example, if I do the dissolution here, and if I do the enzymatic hydrolysis, if I am not doing the enzymatic hydrolysis, I will get the molecule in the form of the cellulose and the starch. If I further convert it into disaccharide form, I will get either the maltose, sucrose, or the lactose. But if I want it is in the monosaccharide form, then I need to go for the enzymatic hydrolysis, so that during the hydrolysis stage, it will break down this particular, you can say the disaccharide molecule or the polysaccharide molecule into mono. Mono is nothing but the single. The single glucose molecule I will obtain by using this enzymatic hydrolysis. single fructose molecule, single galactose molecule can be obtained here. So why it is essential? Because the enzymes cannot degrade this polysaccharide molecule easily to convert it into the ethanol. So you require a very readily available sugar for the enzymes to ferment it to produce the ethanol, and that is what is the main target of this dissolution study. And once you do the fermentation, then as we know the normal fermentation technique, which is very well known technique, obviously. So till then part of actually you require a lot of research. Remaining fermentation tasks and the distillations are very well known part in the commercial industries nowadays. So then once you get the growth of this particular process, you can just use it for the distillation by removing the doing the detoxification of the chemicals and do the purification. And once you purify it, you will get the ethanol, which is of 95 grade, 95% grade, or you can say 99.9, 99.5% based on the distillation technique, which is being used for the distillation of the ethanol from the mixture. So that way, we started to initiate our research. So we first thought, like, let us select the aisles for the biomass solubility. Then how to select those particular aisles? That was another question to us. So what we did is, like, we collected the list of the 400 commercial aisles which are available in the market. And then we thought of like doing some procedural things. Like, let us first of all estimate the properties of the biomass. Like, what is the cellulose percentage present in the biomass? What is the hemicellulose percentage? What is the lignin percentage present in the biomass? Now the question comes is, like, most of the researchers, they don't report actually what is the extractives component in the biomass. But that is very essential when you try to see the biomass as a feedstock for the ethanol. So this removal of the extractive is also important, because sometimes this percentage goes up to 15% also in some biomass. In some biomass, you may find that it is 5% only. So this 15% will lead to a error in the calculation at the later stage when you talk about the percentage of sugar which are obtained from the per kg of biomass. So for that reason, this removal of 10% means around close to 100 gram on 1 kg is a reasonably significant number of amount of unwanted component which are trying to remove in the calculation. So that also we did. We removed the extractives also, and then after extractives removal, whatever the fresh biomass obtained was used for the further study using the molecular modeling. Then we have screened the aisles, and then once you screen the aisles, still I will discuss this part one by one. Still question comes is like how to select the best one. So for that we have done the interaction analysis, and with the above interaction analysis, we could able to select the best aisle. So molecular modeling, the aisle screening, these things we'll discuss in the subsequent slides. Now, the objective here is like just to select the adequate cation anion combination so that it will be very effective in the dissolution of the specific biomass, and understand the mixture behavior, how this mixture is behaving when it is forming a complex, and if required, otherwise we need to design a new aisle if it is not getting compared with the commercially available aisles. So that was also thought process in mind. But then this particular area where I am seeing the design of new aisles itself is a very vast topic to do, because it's not that easy to design the aisle. Even if I design the new aisle, then characterization of that particular aisle itself is a cumbersome exercise, because it should match to all the properties of the ionic liquid, and that takes a huge time. So for that reason, we have used the Cosmores method, which is called as a conductor-like screening model for the real solvents. So as we know the real solvents and the properties of the solvents, because we know what are the cation and the anion we have selected. So based on that, we formulated the method, and then with the help of this method, we could able to screen ionic liquid using this Cosmores method. So now, what is the criteria to be consider for the selection of the screening of the aisles? That is nothing but the activity coefficient, that is called the thermophysical data. We can say the property of the particular aisle. So based on the activity coefficient, we have selected this particular aisle, and then based on the charge distribution of the atoms. But in that, we have given most emphasis on the activity coefficient, right? So while doing this entire exercise, we have selected, say for example, here close to 42 cations here we have selected, and then there are 32 34 anions. If you see this y-axis here, it indicates all the anions, and then this x-axis indicates the cations here. So this entire graph indicates the combination, a permutation combination of these cations and the anions. So which one will be very effective for the dissolution? But then how to guess out that particular part? Then we have used the activity coefficient as a parameter. So the activity coefficient of the particular this mixture, if it is far less than 0, that particular activity coefficient we have considered as a good IS for the dissolution study. And if it is slightly more than that, then it is moderately a good IS, but may not be a very effective for the dissolution of the specific cellulose moiety. And then the top one, which is exactly, you can say, a very bad IS, because they are not effective in the dissolution study at all, because they are not showing any symptoms of dissolution of the cellulose into these IS. So now even if you see this particular rectangle here, this itself is a very big rectangle with too many cations and too many anions. Now, how to narrow down to a best IS from this particular matrix? That was another challenge. So this we have done for the cellulose dissolution. Similarly, we can do it for the hemicellulose dissolution as well. We can do this particular study very effectively, right? So in this case also the same criteria was followed, that same cations and the anions, and again the activity coefficient was based on the similar approach, whatever I mentioned. And then for the bad IS also, so the odd man out basically. So bad IS is nothing but the odd mans. So odd mans we have just rejected accordingly from the particular list. So now based on this entire study, we could see that there are close to around, for example, 19 anions would able to show a very good activity coefficient, which is desirable for the dissolution of the cellulose. So that was one particular findings we could able to guess from this particular screening study. And now select some anions and the cations to study their interaction with the cellulose and the hemicellulose through interaction energy analysis. So this is the next part of the study which we have focused on after screening of the IL. So for that reason, the further study, we studied the interaction energy analysis between the ions and in the cellulose and the hemicellulose moieties here, which are present in the biomass. And then the selected ions is anions, because as I mentioned, 19s were there. So in that 19 also, we screened down to a specific ion which has very good activity coefficient. So accordingly, we have selected these many anions for the synthesis purpose, or you can say for further study purpose. And these are the only cations we have selected for the further study, because the activity coefficient as one of the criteria we have used for the scale down of this particular number of anions to a very limited one. And then the interaction energy calculation, as this is a normal concept in the thermodynamics, you all must have gone through this particular part also, like interaction energy analysis can be studied using this particular equation, or you can say the expression, which talks about the interaction energy analysis, or you can say the interaction energy of a complex. If I have the ion and the solute, now here the solute may be a cellulose, it may be a hemicellulose, it may be another complex. So that indicates the interaction energy of that complex, and this indicates the interaction energy of the individual ionic liquids, which I will use for the further study, as well as the interaction energy of the solute. Solute in the sense is like, suppose if I will do only the cellulose first, hemicellulose first, or maybe the complex one, so that indicates the interaction energy of this solute. So now what is the next step of using this particular concept together? So what we have done is, like, we have done the interaction energy analysis again. So for the selected anions, so we have selected almost close to 14 out of 19, because in the 19 also we have just left out the odd man out. We have just selected the best 14 for the further analysis. Now in this case, if you see here, the cellulose and the hemicellulose, both compound we have used for the interaction energy analysis. So in that case, the acetate ion showed the highest activation, or you can say the interaction energy here, right? In the hemicellulose part also, in the cellulose part also. So these two values indicates the highest interaction energy with anions of these two compound, followed by the others here. So this is decreasing. Basically, this interaction energy further it is decreasing. So highest negative values indicates the very good interaction between the compounds and the anions. So now this is the case of the compound and the anion. Similarly, we need to test these compound with the cations, right? Because anion liquids are nothing but the combination of the cations and then the anions. So for that reason, we need to again screen down the cations according to the same technique. So here also, if you see, so now if you just look at these numbers here, I will just show you the mechanism again further next slides. But you just read out this number so that you will keep it in your mind. So this is the interaction energy of the anions. Similarly, if you try to compare for the cations here, it is relatively less or marginally less than, you can significantly less than that of the anion. So this indicates that anion is playing a major role in the dissolution than that of the cations, right? But in this case also, if you see, so this 1-ethyl 3-methyl imidazolium shown a very good interaction energy with these two compounds, followed by the PM ion and then AM ion and then the remaining one. Clear? So accordingly, we selected now 10 cations here, 14 anions. So if I see the formulation combination of these 14 anions and then the 10 cations, I can prepare huge number of the, I can say, the ionic liquid. But then there is no point in doing all that empty exercise rather than to select the best one for the further study. So for that reason, we have selected the acetate ion, anion, and then the EM ion as a cation, and then this particular mixture of the ionic liquid was used for the further study. So now if you see here, this slide, it shows the experimental dissolution of the cellulose and the hemicellulose, and now the crystalline, macrocrystalline cellulose, because the cellulose is also called as a microcrystalline or the crystalline cellulose because it has a very high crystallinity than that of the hemicellulose, because hemicellulose is not a crystalline material, whereas the cellulose is a highly crystalline material. Right? So because of that, the breaking of the hemicellulose is very easy, but it is very difficult to break out this cellulose using a mild technique. It requires really a harsh technique to break down this particular cellulose. That means nothing but decrystalline this particular cellulose. Okay. So now, if you see here, you may see like there are, if you have shorted only one base tile, then why you are selecting 5? So again, just to check our finding, because all these things we have done up till now is nothing but the molecular modeling things and all. So now, just to have the proof of concept together, so what we have done is like, apart from this EM ion and acetate, we have selected the next best ion and its combination with the anion, as well as the further next of the best cation and then the second best anion. Accordingly, we have done up to 3/4 level of this particular combination, so that we can see, we can practically also prove that whether our finding is matching with the simulation work or not. So we have done that particular study of the solubility of this material using cellulose at different temperature. We started with the room temperature, then increased to higher temperature, 90 degree, 110, 130, 150, something like that, and went up to like 180 also. So, but till in today's research, we will just discuss about the 150 things, because the further work which is still going on in our laboratory, like up to, we are trying to reach up to 200 degree also. So to make it completely a dissoluble material. So if you see here, the solubility is reaching to around like 27 to 30%, right? This is cellulose. Similarly, if you see around this particular hemicellulose fraction, again same ionic liquid, hemicellulose fraction xylene we have used, and we have tested at this particular temperature and this many hours. The solubility, it is also showing around close to 25%, means around close to 50%, 60% of the material is soluble at this particular temperature using this ion. So which is a very good sign for a dissolution study, that we could able to dissolve such a significant number of compounds in the ionic liquid. So now here, if you try to see the mechanism, like as I was saying earlier, like how this dissolution is effective in terms of anions and why not in terms of the cation. The reason to tell you this, like suppose this is a cellulose molecule. So as I mentioned, this is a glucose molecule. All the glucose molecules are attached together, and you'll have the n number like 100, 200, 300, 500. Like there is no limit. Like it is a natural polymer, you'll have n number of these cellulose glucose molecules attached together to form a cellulose. Similarly, is the hemicellulose. It is a cross-linked actually, right? So this is also n number of such cross-linked molecules are there in the hemicellulose, and this is our ionic liquid which you have synthesized or screened and best ion, anion, the cation we have selected. And now if you see here, this red indicates the anion, the blue indicates the cation. So in this case, when you mix this cellulose with the ionic liquid here, so it forms the bond in the form of like OHO with this particular glucose molecules here, if you see, right? Similarly, this cation is also forming a bond in the form of like COH, right? So in this case, one cation or two cations are interacting. So at the time, multiple anions are interacting with this particular complex here. Clear? So similar is the case in case of the hemicellulose. So this indicates the OHO bond, right here. This indicates, this red indicates the anion. This indicates the cation. So we are just showing the partial structure. If you try to see the hemicellulose structure, it's a very big one actually, right? So, but try to just compare our findings here with the help of this mechanism, that why this activity coefficient of the anion is effect very higher. The reason, the interaction energy is also very high. The reason is like the anion is playing a leading role in the dissolution compared to that of the cations that is effective in the dissolution of this biomass using the ion. So that is the finding of this particular second step of the research, which indicates that the anion part of the ionic liquid is playing a leading role in the dissolution, that is OHO bond formation is far stronger. That means interaction in the sense is like it is forming such a stronger bond with that particular individual component there than that of the CHO bond. So it will take out, once you try to do this study at a very high temperature, it will take out that particular specific component from the complex because of the stronger interaction of the anion with the material there. And then as a result, this particular IL, which is EM-IM acetate, is considered to be the best one because it is showing the higher solubility compared to the other combination as well. So now this is the first part of the second part of the study, I would say. Like, so now further what to do with this dissolved biomass now. So what we have done is like in this case, so we have studied the dissolution of this material using this ionic liquid. Now after IL treatment, the next component remains is nothing but the enzymatic hydrolysis, because we could able to take out this cellulose from the matrix. We can say the hemicellulose also from the matrix. Now this cellulose hemicellulose, although it has its own commercial application, but the target here is like to use it for the fermentation. So obviously we need to break down this cellulose into a monosaccharide, that is nothing but the form of the simple sugar. So the hydrolysis is the effective technique to hydrolyze this cellulose to convert it into a monosaccharide. So this dissolution study we have done with the bamboo biomass. So now why we have selected the bamboo biomass? Because the entire northeastern region in India here, it is the third largest area in the country which has a huge plantation of the bamboo. So, and as a reason, the NRL refinery here, they have started synthesis of this ethanol from the bamboo waste biomass only, and it was operational actually last month only. The PM has inaugurated this particular refinery for the ethanol production. So this study we started almost like 4 years before, and now the specific work at the commercial scale itself is starting in the refineries now on the bamboo based biomass. So here if you see this dissolution, now if I go on increasing the temperature, we are not reported here the room temperature study because the solubility of the dissolution percentage was very less. So it's like compared to the 50 degree, it was negligible. So that's the reason we are not reported the room temperature study. However, we have reported the high temperature study 90 degree onwards up to 150. So we could able to see like around 45 to 46% or 47% of the dissolution of the material in the ionic liquid. That only up to 150. If I further increase the temperature, this will go on increasing because the normal trend of the solvent, like once you go on increasing the temperature, the solubility will increase unless it reaches to saturation, right? So now, because of this IL, as I mentioned, the cation and the anion, if you try to make the properties using the tuning of this anion cation, so you can have a very effective anion which you can dissolve a significant number of cellulose and the hemicellulose component in the ionic liquid. So why it was essential, like because we wanted to go for the dissolution study to increase the cellulose accessibility, that is nothing but how to access that cellulose which is present in the biomass, decrease the lignin percentage in the biomass, and then again decrease the cellulose crystallinity in the biomass. So these two things, like one and the third one, it was very effectively done, as well as the lignin could able to remove from the biomass. That was also effectively, we could able to remove the lignin from the biomass. That was one of the achievement of this particular thing. So now the question comes is like, how can you identify like how this particular crystallinity has been decreased for the specific biomass? So for that reason, rather than doing all the chemical tests and cumbersome exercise, we did XRD analysis for the all the biomass samples which were under consideration. So for example, if you see the bamboo biomass, the black one indicates the XRD image of the particular bamboo biomass, which has the crystallinity in the range of around like 69 to 70% here. So which is a highly crystalline material. So once you go on doing the treatment with the ionic liquid at 90 degree, 110, 130, 150, you can see here the crystallinity percentage is decreasing. It is coming to around like 35%. So at 150 degrees C, we could able to reduce the 50% of the crystallinity of the material, which is a significant number in case of the reduction of the crystallinity, such as at a mild condition. Because 150 is not a very high temperature or very high condition here. We can say harsh condition. Rather than high, I would use the word which is called as a harsh. So because 100 degree, 110 itself is a autoclave pressure of the autoclave which we use for normally for the, you can say, the disinfection, right? So for that reason, not in the case of disinfection, I would say for sterilization. So the 150 is comparatively is not that high temperature for the study. So even if we can increase this temperature further, that is also possible. But then we wanted to just test this particular study with this particular range itself first, so that whether we are going in the right direction or not. So decreasing crystallinity in the sense is like it is becoming more amorphous. So more amorphous is like it is more easy to access that particular component in the reaction. So another way is like to do the TGA study. If you don't have like too many chemicals to handle in the laboratories and all, so these are very simple techniques which can be used to analyze whether the particular decrystallization of the cellulose is taking place or not. So this black one indicates for the biomass sample, right? So similarly, when you try to see the other one, so at different temperatures, this TGA analysis was done, where you can see there is a shift in this particular TGA graph. So earlier it was at around like 364 degrees C here when it is a bamboo biomass, and when we have done the ionic treatment, you can see this particular peak is going shifted towards this lower side. That is nothing but the low temperature range. What it indicates is like when it is going to a low temperature range, it indicates that the material becomes more amorphous. Why? Because the amorphous material will decompose at a faster rate compared to that of the crystalline material, right? Because crystalline material is more thermally stable than that of the amorphous material, and that is indicates that the crystallinity of the material has been decreased. And then next part comes in the system is like how to do the enzymatic hydrolysis of the entire biomass, which is ionic liquid treated now. So what we have done is like we have done the enzymatic hydrolysis at a specific temperature of 50 degree, and then the saturated buffer was used to maintain the pH. Enzyme loading we have done in the form of the protein, milligram of protein per gram of the glucose. And the time obviously took around like 72 hours because this is enzymatic study, as you know. So the rate of the reaction is quite slow in case of the enzymes. To take very slow, it's a slow rate. The hydrolysis of the biomass takes longer time actually, but it is very effective because you don't generate any other kind of the we can say a component. We can say the other materials, or you can say the byproduct during this process. As a reason, this is considered as a very effective technique for the hydrolysis. So here we have done the two-way hydrolysis. Ionic liquid treated biomass also we have done the hydrolysis, and also comparison purpose we have done the dilute acid, sulfuric acid pre-treated biomass for the enzymatic hydrolysis, just for comparison whether the ionic liquid treated biomass is giving a good result compared to the commercially available processor or not. That was the basically idea behind this. So while doing this, cellulase enzymes was used. So procured from the Sigma Aldrich, readily available cellulase was used for the enzymatic hydrolysis. Now this shows a very interesting result of the particular hydrolysis research here. Now, if you see this part of the bottom line, which indicates that we have done a very mild acid treatment to the biomass, followed by that we have done the enzymatic hydrolysis here, but still we could not able to reach total reducing sugar yield of more than even 20%. That means the 0.2 molar sulfuric acid concentration is not that effective to decrystallize the cellulose moiety which are present in the biomass. Whereas when we have done the ionic liquid treated things at 110, 130, and 150, we could able to reach up to like 70, close to 70, 67% of the you can say total reducing sugar. So how to calculate total reducing sugar, that I will tell you further. But in that we also measure the total glucose yield. That means we are interested in only the glucose at the beginning. So around 90%, or you can say 88% of the glucose we could able to remove from this particular available enzymatically, or you can say ionic treated biomass. So that was a very significant achievement of this particular research actually, where the 88% of the glucose only we could able to produce from this hydrolyzed process actually. So here, as I mentioned, around close to 80% of the glucose yield was obtained when the ionic liquid treated biomass was used for the enzymatic hydrolysis. And when you see the conventional process where the sulfuric acid was used in the ratio of 0.2 molar, even temperature was around like close to autoclave temperature 121 degrees C, still we could not able to get a relatively good amount of the sugar. That means this percentage of the acid need to be increased further to release or decrystallize the cellulose first, so that it will release the sugar in the enzymatic hydrolysis process. So this indicates the chart, like we did the research for 0.4 molar sulfuric acid, 0.6 molar, till we could not able to get a significant number actually of the concentration of this material here, right? But then what we did is like, just for the comparison purpose, we thought of like use the 0.2 molar acid hydrolyzed biomass and again treat these hydrolyzed biomass with the ionic liquid, because when we use the acid for the hydrolysis of the biomass, so at least it will do some kind of damage to the biomass and its bonds, or you can say the complex of the plant cell bond. So if we use that material again for the ionic liquid, whether it is giving any enhanced result or whether there is giving any enhancement in the reducing sugar or the sugar yield, that was the only idea to check behind this particular research here. So we thought of comparing the study with the 0.2 molar hydrolyzed biomass as well as directly treat with the ionic liquid. So this study shows here the finding of that particular research, because here you can see this black indicates bamboo biomass which we have used. Then the red one is the combined treated biomass, that is 0.2 molar followed by the ionic liquid, and this is for the pure ionic liquid. So still the pure ionic liquid is leading in case of the dissolution study, whereas in case of the glucose yield, here it shows that glucose yield in both the cases is more or less same. So now the question will come in the mind, if the glucose yield is same, why not the TRS yield? Because the TRS yield indicates the total reducing sugar which you are obtaining from the hydrolysis of biomass. So in that case, it will be a mixture of the glucose, xylose, cellobiose, and many others. So that indicates the total. So in that case, the combination, even if it is a 88% here, and why it is going? Because here, if you see, it is going beyond total reducing sugar, is going beyond even the 95% here. Whereas the glucose percentage is more or less same in both the cases. But then, as if you are getting even the same glucose percentage by combined treatment as well as the ionic treatment, then why not to go for only the ionic treatment technique? Because I don't need to waste time again in doing the 0.2 molar hydrolysis of the biomass using sulfuric acid. So that was the idea behind this. So that also confusion got actually, you can say, analyzed in our research, that rather than going for the two-stage, you can simply go for the single-stage ionic liquid process here. And that tells is like around 85% of the glucose yield was obtained by the combined treatment of bamboo biomass. And then if I do the same with the ionic liquid, so I could able to reach around like close to 90%. So this is a very significant finding here, that ionic liquid itself alone can do a role of leading this particular process. So now what to do next? Because once we have obtained this sugar, what to do with this sugar? So we have done the ethanolic fermentation actually. So if you see in this case, so this shows the xylulosic ethanol production. That means we have used the xylose and tried to do the fermentation of that particular xylose, whereas the glucose is still present there in the mixture. But then, as this PCS50 is a microorganism which we have used for this particular ethanolic fermentation, so it was very selective in case of the fermentation, which has only started reducing the xylose concentration at the beginning and producing the ethanol, and it was not having any excess, or you can say the reaction with the glucose. So the glucose percentage remains the flat, almost the same here, because we did not see the change in the glucose actually there. It is almost the same, right? Whereas the xylose percentage is decreasing, whereas the ethanol percentage is increasing here. So we could able to reach to around like 18.5 gram per liter of the concentration of the ethanol in the mixture. That was a very good number in case of the fermentation process. And also we have done with the glucose separately here. So this is the glucose ethanol fermentation, and this is glucose concentration which is decreasing, because this is very well known like how it will decrease. So we have used the glucose concentration in this way, how it is decreasing, and this blue indicates the ethanol concentration, how it is increasing in case of the glucose. So glucose gives relatively a higher ethanol concentration than that of the xylose here. So that way, whatever the technique which we have studied, all the techniques were significantly helpful in converting the lignocellulosic biomass into a reducing sugar, and further downstream of the reducing sugar was possible to convert it into the ethanol as well. So that was the finding of this ionic liquid study. So apart from that, as I told you, like there are other green processes also being used in the research. So we thought of doing the research with the subcritical water technology. That is, again, here there is no chemicals required in this process. We can normally use the water and the temperature in the range of 100 to 374 degrees C, and the pressure, like, we can vary from like 100 bar to you can say up to 200 or maybe like you can say 10 megapascal to 22 megapascal range temperature pressure you can vary, and you can see how effectively it is dissolving this particular complex, or you can say component of the biomass in the water. Because when the water reaches to its critical point, so 370 degrees C is the critical temperature of water, and 22 megapascal is the critical pressure of the water here. If you can see on this right corner graph here, which shows the critical pressure here, right? So during this stage, the water behaves like a kind of solvent basically, right? So it will try to dissolve, and it also has a very good ionic strength at that particular temperature and pressure. Because of that, high selectivity and high diffusivity and wide dielectric constant and the polarity, it will try to take out all those complexes which are soluble in that particular phase there, and it will selectively take out that, right? So because of that, it will take out the cellulose and hemicellulose fraction very easily, and sometimes it also try to do the hydrolysis parallelly along with the cellulose and hemicellulose hydrolysis. So that is another important point of this particular process here. And during this process also, we could able to extract a good amount of the you can say essential oils. If you know the citronella biomass, which we are normally having this percentage of the oil in the our all-outs. If you see the all-out bottle, it is having this citronella oil in it, which is composition. Obviously, there are different chemical or different solvent together, but main is nothing but a citronella oil, because it has a capacity of the mosquito repellent, right? So we could able to extract this particular oil also from this glass. So what to do with the spent biomass? So for that reason, we tested this spent biomass in the subcritical water technology as well. That was the research we did, and this was also a very good finding in our research. And we have done it in the laboratory scale reactor, like autoclave kind of a reactor. So this was the reactor which we have used for the research. If you see here, so different assemblies of this particular reactor. And once we add water along with the biomass in the reactor, so this yellow part indicates we have fed the material inside the reactor. Then we can just close the reactor and then start the stirrer. So once it starts stirring, so and the temperature got increased. So you can see there is a change in the color of the material is taking place, right? So because the temperature of got increased now, so it has reached around like 200-degree temperature. If you see, the pressure is around like 15.6 kilogram per centimeter, right? So that way you can vary this temperature here, and then we can also require, if you do the pressurization, you can do the external pressurization with the nitrogen stream, because nitrogen being the inert, so you can pressurize using the nitrogen as well. And these are the water pump to feed the water in. So to cool the reactor. So what we have done is like we have used a nitrogen cylinder to pressurize the reactor again if required, and then further the nitrogen gas will go inside this particular reactor. It will try to pressurize the system. And this is also helpful when you have to take out the sample. Basically, you just pressurize it. So the sample tube is there, which is attached to this particular wall here. You can take out the sample from the sample wall. And in between, if the temperature is going up, so what we do is like, oh sorry, the sample wall is on this side, if you see here. So this red wall will come out and will get collected in case of the sample vessel. So it will get collected here. So we can pressurize the nitrogen accordingly. We can collect the sample in the sample holder. And meantime, if the temperature goes beyond the range, then we can just cool down using the water inlet outlet jacket here. So that way we can maintain the temperature inside the reactor to a reasonable level, and then I use it for the further purpose. So this way we have done the subcritical analysis or subcritical treatment of the spent biomass. Another interesting part is like we also do the supercritical fluid extraction here, although this is a slightly offbeat of the today's fuel part, but then is very essential because nowadays this particular industry is also growing significantly, where we are trying to extract this ginger oil, actually the ginger oil, which is called as a ginger oil, which has a very high value in the medicinal as well as in the food industries actually. So this is also one of the small part of the research which is going on in our laboratory right now. And then another interesting part of the greener fuel is nothing but the algal biodiesel. So we are working on the algal biodiesel is like can say cultivation of the microalgae using the waste system, and then use the harvested microalgal cells, because as we know the algae is nothing but equivalent to a plant material, but only it has been grown in the water rather than on the land. So these green parts are nothing but the microalgal cells which we collected after harvesting, and then after harvested algae we have used for the hydrothermal liquefaction to produce the bio oil. So this is one of the important research also nowadays, like refineries are going towards this production of the bio oil rather than having too much dependence on the crude oil. And then another part of his green fuel is nothing but pyrolytic process. Here we are working on the pyrolysis of the direct seeds, actually the castor seeds, and then the seeds which are non in use basically in this part of the country, that is northeastern part of the country. So here the rubber plantation is huge. So we have used the rubber seed directly for the pyrolysis process here to produce the bio oil and the biochar. So this biochar also has a very good commercial market. It can be used as a soil amendment agent as well as it can be used as a purifier, that is nothing but the air purifier, or you can say the gas purification system as well. So this is also one of the research in the area of green fuel we have, because here we have not done produce any waste in the entire processing. Whatever the seeds we have used, the entire seeds, these are nothing but the kernels of the seeds, and these are the shells. So shells were used to pyrolyze the biomass, and the kernels were used to produce the biodiesel. So nothing is getting produced waste in this particular industry here in case of the rubber seed. So there is a zero waste industry, I would say, except you can say the amount of the water which is required during this particular processing. So these are about the references, like the references which we have used during this particular work, and then for preparing this presentation as well. And acknowledgement, actually, as this work is being carried out in collaboration with the Professor Kamal Banerjee, actually, who is an expert in the field of this molecular modeling, and we are expert in the field of the experimental technique, actually. So they give us the ionic liquid, and we do the base scale study of dissolution of the lignosus biomass and the characterization and all. And Dr. Moodmon, actually, he worked on this field earlier in our laboratory. Now he is doing postdoctoral fellowship at USA. And again, Dr. Narendra also, he worked with us on the ethanolic fermentation technique. Now, he was earlier in NIT Andhra Pradesh. Now also he is doing postdoc in this similar laboratory actually. So yeah, these three are nothing but our good collaborator in this area of degradation of biomass. And this is our bioenergy research lab group. Those are working in the different topic of microalgae, extraction of the essential oils, and then the food industry related topics as well. So thank you for your kind attention. And if you are all excited to have interactions, so we can have few questions quickly.
Yes, participants, you can just raise your questions if you have any doubt.
I hope actually I have reaching to the conclusion in time, because I would say it was up to 3:30, but I was trying to finish it early so that we can have some time for Q&A.
Yes, yes, that would be more better. That because we are fortunate enough to have you live today, because all the time we used to have the NPTEL lecture, and today we used to have the experience of your live your presentation, and it was been since that a very depth kind of research you had been doing in this particular field. I think Ashwini madam, you was raising your hand. Any question from your end, Ashwini madam? Just one question from my end. That most of the time we used to just go through the research, and we used to see that biodiesel from the algae. So any that issue regarding that developing because the huge amount of that percentage of oil which has been there, so amount of algae which will be required, a huge quantity will be required. So the conditions and the raising this particular algae, is any issue has been there for facing this particular algae?
Yes, actually that's the reason. Actually now what is happening is, like, many researchers, they are going into a mixed consortia rather than using a single microalgae for the cultivation, because maintaining that uniculture is very difficult during the entire span of the growth of the microalgae. So, and then we cannot avoid the contamination also, because contamination bound to happen by bacteria and other things which are present. If you are doing it in the open pond, the contamination is bound to happen. So that is another thing in the macroalgae area. And now that's the reason now they are going towards, rather than just biodiesel, why don't you go for the value-added chemicals from the macroalgal biomass as well, which is more adding the value than only the biodiesel. So those hurdles are there, no doubt. But now many things are happening parallelly. And then we are also working in the consortium system now, rather than just a uniculture. 2 macroalgae or 3 macroalgae can be grown together, which is having a symbiotic growth. So that will help in the future.
Okay. So any few more questions from your end?
Sir, I have one question.
Yeah.
Yeah, sir, you have explained you have given the insights on the enzymatic hydrolysis of biomass.
Right.
Yeah. So, is it a fast, means like the reaction rate is faster in the enzymatic hydrolysis? My question is, as
No,
compared to the other ionic liquids, as compared to the others.
No, it's very slow actually, because that's the reason the enzymatic hydrolysis, we cannot go beyond a certain temperature, like 50 degrees, because otherwise it will affect the enzymes activity. If you go to the higher temperature, so these are not good for the enzymes, because enzymes won't sustain really higher than the 60-degree temperature even. It's impossible for some enzymes, right? So that's the reason, if the temperature is low, the rate itself is very low in case of the hydrolysis of this biomass. So that is the problem happens with this particular enzymatic hydrolysis process. And then that is the only step which takes longer time. Otherwise, remaining steps, except enzymatic hydrolysis, fermentation also, you can finish within 32 or 40 hours. But this process, sometimes it may take around 70 hours also.
Okay. Okay, sir.
Okay.
But the glucose yield you got is very good. That is 80% glucose yield you said.
Yes.
Sorry?
That was close to around like 80-85% of the glucose yield we could able to achieve. Yeah.
Yes. The results were good, but the process is slow.
Process is slow because there is no other alternative for the enzymatic hydrolysis. That we need
Okay.
to follow the same thing. That is the issue.
Okay. Thank you so much, sir. Thank you.
Yeah.
Dr. Sadanand Goye, you had raised the hand. Please have your question, sir. Goye, sir. Sadanand Goye, sir, you raise your hand.
Sir, my one question is,
Yeah.
can we use this enzymatic process for hydrodesulfurization of crude oil directly? So that desulfurization of crude oil.
Desulfurization of crude oil is also possible, but then again it depends actually the viscosity of the crude oil, like how viscous it is, right? And then you have to also use a selective sulfur reducing bacteria only, because as we are doing for the hydrodesulfurization, that is we are doing the desulfurization of the sulfur which is present in the oil using the hydrogen as a reacting agent. So that is also possible. But again, that process is also very slow. We did some work on this part earlier, but it takes a huge amount of time for the desulfurization. So that's the reason industries go for the catalytic system using the hydrodesulfurization, using zeolite as a catalyst, or we can say very effective catalyst, which can be achieved very quickly.
Okay, sir. Thank you, sir.
Good, sir. I have a question. I mean, it's not a question, it's an inquiry. Satyajit, sir, am I audible?
Yes, you're clearly audible, sir.
Good, sir. Thank you for a wonderful presentation. On one of your slide, you showed the setup of supercritical fluid extraction, right?
Right.
I was wondering, like, how much it costed to you, and from who is the vendor? Because I'm also planning to set up that unit at Chemical Engineering Department of MGM University.
Okay.
By the way,
Actually,
my name is Sadanand Guhe. I'm calling from MGM University, Aurangabad.
Okay. So actually, we have this system we procured in 2016. It's long back actually. Now the costing has gone up like anything, and we procured it from the water. So now, as you are from Aurangabad, in Mumbai also there are 2-3 vendors. They provide these kind of systems actually. You may contact them. Also, you can contact Waters for this system. Now they have also revised little bit this particular system with slight modification in it.
Okay, maybe later I will get in touch with you, and then you can supply the company.
Sure.
Hopefully, we can work together on supercritical extraction in future.
Sure. Why not?
Thank you very much, sir. Satyajit, sir, thank you.
Thank you, sir. Thank you, Sadanand, sir. So, any more question? Okay, I think no more questions.
No more question,
Yes. Thank you, VAIBHAV sir, for a wonderful presentation and showing the deep research, the way you have been carrying out. Thank you so much. So I will request Rushali madam that formally just conclude this session by giving the vote of thanks.
Yes, sir. Thank you. Thank you so
Don't
much,
need
sir.
to call sir actually.
Yeah, it's
as I'm your junior, don't worry.
Because it's nice that the role has been changed. It's really happy and really feeling proud.
Yeah. Thank you.
Good, sir. Thank you. Good, sir.
Thank you.
Yes, one of your again colleague Manish has been there.
Oh yeah.
Manish Patil.
Oh, Manish Patil is there now in the Datta yeah?
No, he's been there at Avantika University. Avantika University.
Oh, which university?
Avantika University.
Oh, switch on your. Oh my God, you have changed a lot actually. I also changed, no doubt.
Nitin Rane sir is also with me.
Oh, he is there.
He is Vice Chancellor and I am Registrar.
Oh, okay. No, I know he is there in Avantika University Vice Chancellor. I thought he is there in with you now today.
No, he is in another meeting.
Yeah. I met him actually because when he was here in this MIT campus of Meghalaya.
Yes.
He was here, na? So then he moved to Avantika University.
Yes.
Yeah. So nice to see you also after a long gap, actually, almost
Yes, yes.
after
Almost 25 years.
25 years.
Yes, yes.
Yeah.
Manish, Nitin Rane, we are all in contact frequently.
Contact.
For any reason, we used to have interaction.
Yeah.
Satyajit, let me jump in. Recently,
Yes, sir.
Patil sir has been nominated on Academic Council of MGM University. We
Oh,
recently
yes.
met at convocation, fourth convocation.
Yes,
Patil sir,
congratulations,
namaskar.
congratulations. Nice.
Namaskar, namaskar, sir. Yes.
Patil sir, namaste.
Namaste, sir. Namaste.
Nice to meet you, sir, all of you.
Nice. So this is somewhat a very small world of chemical engineering.
Yes.
All
Yeah.
after I think at the VAIBHAV, we have been just meeting after 25-30 years.
30 years, right? Almost.
Yes.
It's
So
nice to see all of you actually after such a long
yes,
gap of like 25 years.
yes.
Although it is online, but still it's good.
Still, it feels that
Yeah.
at least we see our faces.
Yes.
That's good.
It's a good platform, actually.
Yes,
Good
yes.
platform, right?
Because see, if you plan to have a offline conduction, there are a lot of restrictions are there. So
Yes.
calling to you in the Mumbai and having the session, because you might be busy with some other work, and
Right.
participant might be also having some particular, because nowadays each and
Mhm.
everyone is busy with all the other activities. So it is
Right.
very difficult to conduct the offline. Otherwise, we could have been planned for the offline. But this was
Right,
one of the good way. All we had been learned through the COVID. This is one of
Yes.
the mode that we can have the interaction through this online mode also.
Online mode also, right?
Yes. Okay. Thank you so much. Rushali madam.
Yes, sir. Yes, sir. On behalf of the Department of Chemical Engineering and the entire organizing committee of this AICT Atal Faculty Development Program, I extend our sincere gratitude to Dr. VAIBHAV GOUD sir, Professor at the Department of Chemical Engineering, IIT Guwahati, for delivering such an insightful and thought-provoking session. Sir, your real-world examples, research perspectives, and future outlook have inspired us to think critically about integrating sustainability into chemical engineering practices and research. During your session, you have made us knowledgeable about the various pre-treatment methods of the production of fuel from the biomass. And then you have given the you had a in detail discussion of composition of biomass and also the dissolution of biomass. You have made us knowledgeable about the enzymatic hydrolysis is enzymatic hydrolysis of biomass, and then how it has given the good results, yet it is a slow process, but it has given the good results. Also, you have given the how the ionic liquids are superior in biomass dissolution. Thank you so much, sir, for this one. So once again, we sincerely thank you, Dr. VAIBHAV GOUD sir, for taking time from your busy schedule to share your valuable knowledge and experience with us. We hope to have many more opportunities to learn from you in the future. Thank you, everyone. Thank you, participants, for being remain in the whole session, and thank you for asking the questions. Thank you, everyone. And thank you, sir, once again for an
Thank you.
excellent and engaging session. Thank you.
Thank you
Thank
for
you.
giving me today as well.
So Prashant Ingule sir, what do you say that next for the next session? Next session is for Abhijit Adav's session. So
So I will close the
So
meeting.
we are
and
log off now?
yes, however, sir, you can now just log out now.
Okay.
Yes. Thank you so much.
Thank you all.
Yes, sir, we will be disconnecting the link, and again we will ask the participant to join
Yes.
for the technical recording purpose and all the things. So participants requested, Abhijit sir, we will just disconnect the meeting and we'll start the meeting so that the recording will be continue for the another 2 hours.
Sure. Yeah, sure.
Prashant sir.